So good morning, good afternoon, and good evening, everyone, based on the time zones you all are coming from. So guys, before we start with the session, can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Before we get started, let me quickly introduce myself to you all first. And I have been working in this IT industry for more than 12 years now, where I have been leading the global design and development teams for designing enterprise solutions for different industry verticals, including insurance, retail, banking, pharmaceutical, aviation, and location-based services. And mostly I have been active in the markets of India, US, Canada, Singapore, Australia, and other Southeast Asian markets so far. And in terms of the trading front, I have been working as a corporate trainer as well since last 5 years, where I have been training the workforce of companies including Accenture, Mercedes, EY, Capgemini, Adobe, Credit Suisse, NIT, Grab, among others, in making sure their workforce is all updated in the current trends and technologies, specifically in cloud computing, in data science, and in big data engineering technology. That's in a nutshell of what I've been doing for almost 12 years now. So now let's get started. So we have gathered for a discussion on the AWS certification training, which will make sure that you all have the complete knowledge on getting trained on top of AWS associate level certification. So the main agenda for that we are going to cover in this entire module is we are going to discuss on what exactly we mean by cloud computing, what is virtualization, what are the advantages of cloud versus on-premise solutions, different cloud computing models, what are different cloud deployment models, what exactly is AWS, why we have to choose AWS, and how the management console works and how we can get registered, and what are different services available under AWS, and then we are going to discuss on the use cases step by step as we move further with the course. Before we proceed, guys, there are a few pointers that we have to keep in mind, and if you keep these pointers in mind, then we'll be having a really good session. So again, in case you have any questions or any doubts on the ongoing topic, you can ask as many questions as you want. But in case you have any questions that is not a part of the ongoing topic, then please reserve or please hold on to those questions, and then towards the end, when you open up for the question answer round, you can ask those questions even if that has nothing to do with the ongoing topic. So in that case, we can maintain a good balance between the discussion on the topic and also on the question and answer round as well. So first of all, let's start with a discussion on the cloud computing. So if we talk about cloud computing, then cloud computing is basically letting us use the infrastructure which has been deployed by someone else on a simple subscription basis. That exactly is what we mean by cloud computing here. Now, when we talk about clouds, if we go back 15 years, then at that point of time, if we had a requirement of deploying any cloud solution, any solution, or for example, any application, then there we had to purchase a complete stack of servers. We had to set up the entire servers in our own infrastructure, as in our own, we can say rented or bought place. Then we have to hire individuals in order for a proper maintenance of those servers, software installation, operating systems, the networking, load balancing, maintenance, scaling up and down the resources. I mean, these all pointers we have to take it at our own end, correct? So either we can use, so again, being a business owner, either we have the two options. Either we can focus our entire time on doing this entire infrastructure, or we can focus entirely on our business, right? And when we are deploying every solution on, we can say offline, then either we have to hire separate individuals that will simply increase the cost, and that will not allow us to have a high availability in different parts of the globe as well, correct? And now what we have now, there's already certain vendors who have done the entire infrastructure set up at their end, and they are allowing us to use their services through internet, and that too at a simple pay-as-you-go model. That means we have to pay only for the resources that we are going to use, nothing less, nothing more. That exactly is how it is structured in terms of cloud computing offering. And when we say virtualization, so virtualization is basically the creation of a virtual version of something, or we can say, let's say we are trying to deploy any kind of virtual solution in terms of, now we are trying to create some, we can say a virtual service. For example, let's say when we deploy any server, either we can deploy a physical server or we can deploy a virtual server out of the physical hardware, so that we don't have to worry about setting up a physical device or doing any kind of physical setup at our own end. That exactly is what we mean by virtualization. So for example, well, let's say here we can create a virtual server. We can create, in terms of Mac OS machine, we can simply use the hypervisor VM to simply create another instance where we can allocate its own memory, processing power, disk space, and then we can treat it as a complete different system. So technically, they both are running on the same hardware, but in different environments as a part of virtualization. Next is we have cloud models and deployments. So basically there are three platforms that we have to take care of. We have infrastructure as a service, platform as a service, and then we have software as a service. When we talk about infrastructure as a service, let's understand what exactly we mean by that. Now, let's say if we go back almost 15 years, at that point of time, if we had a requirement of buying any PC, then there were multiple vendors. So now suppose a vendor was there and that vendor only gave us the entire infrastructure. That means that vendor gave us the entire piece of hardware in terms of monitor, keyboard, the motherboard, RAM, hard disk, processors, network card, graphic cards. That means we are getting the entire infrastructure with us, but we have to take care of the entire operating system installation. We have to take care of the virtualization of the drivers, networking, everything had to be configured at our own end as a part of infrastructure as a service. Whereas suppose in the same market there was another vendor, and that vendor not only gave us the infrastructure, but that vendor also gave us the entire operating system and drivers and networking, all the components already pre-configured. Because now we don't have to worry about setting up the entire drivers, the networking, the operating system. These all things are already taken care by the vendors. So when we get not only the infrastructure, but all the operating system, maintenance, drivers, and networking already set, then that is a part of platform as a service. And then we have software. Suppose in the same market there was another vendor, and that vendor not only gave us the entire infrastructure, not only gave us the operating system pre-installed, but this vendor also gave us other application bundles already configured. For example, here we are getting the entire MS Office suite. Here we're getting multiple video editing applications. Here we also getting the entire security applications already configured. That means here we don't have to worry. Here we are not getting only the infrastructure, but not only the entire platform, as in the operating system and the maintenance, but here we are getting all the piece of all the applications also pre-configured. And this setup is called as software as a service. That means suppose if there's a guy who wants to work on spreadsheets, so this guy can go to infrastructure as a service, and this guy can request for the number of, we can say, this guy can request for the actual infrastructure, but again this guy has to worry about, this guy has to take care of the installation of operating system, drivers, the actual applications, and then only this guy can start working on spreadsheets. This guy can also go for platform as a service. And here, this guy does not have to worry about setting up the operating system, but this guy has to worry about setting up the entire application, and then only this guy can get started on working on spreadsheets. Or this guy can go for software as a service, where he or she doesn't have to worry about doing anything. Each and every component of the entire infrastructure, operating system, and even the entire MS Office suite is already configured. That means this guy can start using the services right away without doing anything, just like a plug and play device. And that's why these are the three most popular cloud service models available in cloud computing environments. So are we all clear on the concept of service models till this point? Please give me a quick information, everyone.
Yes.
Perfect. Thank you for the information. All right, next is we have cloud models. Now, this is what we had discussed. So when we are talking about on-premise, we have to take care of each and every components. That means from data center to applications, we have to take care at our own end. Whereas in infrastructure as a service, from data center till virtualization, we have, now these things are already taken care by the cloud computing vendors. And we have to work on operating system till applications. Whereas in platform as a service, like we have every component from the data center till security. These things are taken care by the cloud computing vendors, whereas we only have to worry about deploying our application code in the platform that we have been given. And then in software, everything is pre-configured. We only have to pay for using these services. Now, the best example is like we have Netflix, we have Amazon Prime, we have Google Maps, we have the entire Google suite, the entire social media platforms, Dropbox. These are what? These are simply the application that has been deployed, and we can start using these services just by paying the small fee. Whereas platform as a service, like we have multiple examples such as AWS Beanstalk. So Beanstalk is simply an application. For example, if we have a PHP application with us, our developers have a PHP application, our developers have a Node.js application. So without worrying about setting up the environment first, because if we are deploying PHP and Node.js application, we have to set up the entire environment first. We have to provide the entire configurations at our own end, correct? So instead of doing that, our developers can simply choose the environment in which they want to deploy the solutions, and where each and every configurations are already done, and they can simply push their code and have the applications deployed in the exact server configuration that they want. And that exactly is a example for platform as a service. And AWS and all the other cloud computing platforms, they are also example for infrastructure, where we can choose the exact hardware that we want to configure. That means what kind of servers we want to launch and with what capacity, how we want to scale it up. So these all are examples for these three main service models. Then we have deployment models. So again, deployment models, we have three: public cloud, private cloud, and then we have hybrid cloud. So public cloud is when we are deploying any solution that is meant to be accessed by the public. That means anywhere coming from in the internet. Like we have front-facing applications. Like we have now the example is AWS, Azure, Google platforms, IBM Bluemix. And private cloud is when we are designing any solution for the enterprises with having limited connectivity. That means anyone since this is meant to be used by the enterprises, so we deploy them on the private cloud, and then we take care of the entire networking components at our own end. Whereas hybrid simply mixes both of these components. Like for example, if we are deploying any B2B segment, we can say e-commerce solution where we have different platforms for the customers coming from the internet and different platforms for the vendors, where they can log in from their own end and have a complete, we can say, restricted access to the environment. So again, we can combine both of these public and private cloud and offer as a part of hybrid solutions. Now, AWS has been most popular cloud computing platform, having the biggest market share of around 42%, and then followed by Microsoft Azure having a market share of around 18%, and then followed by GCP, as in Google Cloud Products, having a market share of around somewhere between 8 to 11%. And then there are multiple other vendors in the market, like we have DigitalOcean, we have IBM, VMware, we have Alibaba as well in the cloud platform service. So AWS was launched back in 2006, and since then it has been the global leader because of multiple reasons, because of its easiness with which we can start using the AWS services, and the scalability, the performance, and the entire, we can say, a fluid user experience in deploying the entire solutions here. And currently there are 157 plus services available in AWS with for different categories. For example, here we have services for computation, storage, networking, databases, IoT, AR, VR, for data migration, for data storage. So we have multiple services out there. And here in this entire training, we are not going to focus on each of these 157 services. We are going to focus only on some selective services, because again, at the end, our goal here is to focus on the completion of our associate level certification. And that exactly is what we are going to focus on. So although again, we are going to focus on the certification, but again, in case we are going to discuss some services where some of the components are practically used when we are deploying, when you're working as a solutions architect, then we are obviously going to discuss those pointers as well. And AWS has been the most popular cloud platforms, as we can see here, where AWS simply tops the chart here, and then followed by Azure, and then we have GCP. So AWS has been the market leader. It has more market share. It offers a complete user-friendly and feasible and low-price services. And they are now almost every of the Fortune 500 companies, they are using the AWS platform for their deployment purposes, including Nokia, Kellogg, Samsung, Lionsgate, Nintendo, Ubisoft, Adobe, Netflix, Toshiba, Nasdaq, Philips, MediaCorp. They all are using services for AWS. And this is how the entire dashboard looks like that we are going to look at, how exactly we can sign up for the dashboard in order to get started. And there are multiple domains available in AWS that we are going to focus on. Like for computation, we have EC2, Beanstalk. For networking, we have VPC, CloudFront. Now, when we are going to discuss on computation services, we are going to discuss on EC2. EC2 is basically a virtual cloud, a virtual service, a virtual servers that we can deploy on top of cloud platforms. Just like in Azure, we have virtual machines. If let's say if we are deploying any solution, any app, any solution, then obviously we do need a server for that. And using EC2, we can deploy these servers as per the requirement. And then we are also going to discuss services like we have Lambda being the serverless computing platform, and then Beanstalk, which is offered as a platform as a service where we can choose the environment, for example, PHP, Node.js, Docker environment, and then we can push application codes inside it. And then we have VPC. So VPC is basically a service that allows us to create a completely isolated network. For example, let's say if we want to deploy multi-tier architecture, where we need to maintain our own networking layers. For example, we want to deploy the web servers, then we can choose them to be deployed in the public subnets. When we're deploying our application servers and databases, we can deploy them in the private subnet, where we can have complete control on these resources for the internet, and then we can choose accordingly. That means how much of access these are going to have one by one. And then CloudFront is basically a content delivery network where we store data in multiple edge locations for a faster delivery of the content, to maintain the integrity and to reduce the latency, that we are going to discuss step by step as we move further. And then we have Route 53 service, which is basically a service deployed by which is basically used to map our domains and define multiple routing policies for the given services. And then we have Amazon S3 being a part of simple storage service, where if you want to store any kind of documents, just like we have Google Drive, we have Dropbox, where we can store any kind of documents, and if you want to share them, then we can directly share them as well. And then we are going to discuss on EFS. EFS is also part of file structure. So in storage services, we are going to discuss on mainly on three components: EFS, EBS. So EFS refers to Elastic File System. That means if we have a requirement of creating a complete file structure, that we need to host on a cluster of servers. That means suppose if we want to host it on 500 servers, 100 servers, then we can create that entire file structure, and then we can host it on the complete EC2 clusters. We can do that. Then we are going to discuss on the RDS. So RDS is basically a relational database service offered by AWS, through which we can store multiple database. Now here we can choose from multiple engines available, like we can choose from MySQL, Oracle, MariaDB, or Postgre. We can choose from the Microsoft's own or Amazon Aurora service as well. And we can choose any of these database engines. We can define the entire configuration of the instance on which we want to deploy them, the entire networkings, the entire backup maintenance. These things are again already taken care by AWS. And then for storing NoSQL databases, we have a service that we are going to discuss that is called DynamoDB. So basically, it's a NoSQL database service where we can store unstructured data set, and we can store them as a, and then we can have the component of vertical scaling also allowed, where we can add more number of we can say if we have a requirement of handling large number of items. For example, if our website has million items that needs to be stored, and that needs to be accessed in we can say with a much better performance than our normal database, then we can use these kind of DynamoDB services such as NoSQL devices. And the common use case for deploying any solutions on top of cloud is, let's say here we have a website, and obviously this entire domain is something that we are going to host on the Route 53 service, and then we can choose, and if we have a multi-tier architecture, we can create our own VPC here, where we can define the security groups for the web servers. We can define databases, application services in different subnets. Where we can define the entire ACL as an access control list, how exactly we want these services to be given the access to. And then for the monitoring purpose, we can use services like we have CloudWatch and SNS for monitoring each and every component of these different services one by one. So the same architecture that we had deployed on top of corporate data center, we can choose multiple services for allowing us to do the same thing. As we discussed, for mapping the domain, we can use Route 53, where we can create our own VPC. Then we can create multiple subnets in this entire VPC to deploy the database in the private subnets and deploy the servers in the public subnet. And then we can use EBS as a part of Elastic Block Store. That is a storage for each and every individual instance. And then for monitoring purposes, we are going to use CloudWatch and then connect that CloudWatch with the SNS. So all of these components, and again, IAMS refers to the Identity and Access Management Service, which is basically used to define the access level for each and every user who is going to use our AWS account. And these all combination of how these solutions are deployed, what are the properties, and what are pointers we have to keep in mind while deploying each and every of these resources. We are going to discuss that part step by step as we move further with the course. So first of all, let's see how exactly we can deploy the resources here. Just a moment. Now, in order to log into the console here, we can use, okay, let's do one thing. Let's open this in order to log into the AWS platform for the first time, we can use aws.amazon.com, where we can see the homepage for AWS platform. Now here we can see the list of all the services available. We can see what all services are available in AWS in different categories. So if we scroll down, we can see the services available for analytics, for application integration, for cost management, blockchain, business application, computation services, containers, customer engagement, databases, developer tools, and user computing. All of these different services are available with us, including the IoT machine learning components. Now, in order to get started, first of all, we have to click on create an AWS account. We have to go ahead and click on it. And just like we sign up for any other website, we have to enter our email address, our password. We have to confirm the password that we are going to use, and then we are going to use an account name. Once we enter these details in the next screen, we can choose whether we want to create a personal account, or if we are going for the enterprise account, then we can choose the account option as business, where we can enter our business details as in our registration number, so that we can get the entire taxation and invoice on behalf of the company itself. And if you are going to use it for a personal account, we can sign up as a personal account available in AWS. And just like every other cloud computing platforms, we do need to add a valid payment method. So we can use any of the credit or debit cards from Visa, MasterCard, or Amex. And once we verify this, and again, we are going to be charged a nominal fee for authentication. That is, we are going to be charged 2 INR for making sure that whatever payment method we are adding, that is valid. And after we have added the payment method, then it may take up to 24 hours for our account to be activated. So some of the services may get activated right away, but some of the selected services may take up to 24 hours in order to be fully activated. And once we have successfully configured, we will be able to log into the dashboard using the same credentials that we have chosen. And to see what all services we get as a part, now AWS offers us a free tier account. So when we say free tier account, that means in free tier we get the access of selective services that we can use under limitation for free up to 1 year. So here we have the entire detailed overview of what all services are available under free tier and what is the limitation of using these services under free tier for the complete year. For example, if we talk about computation services, then we get 750 hours of EC2 usage that we can go for as a part of T2 micro usage on a monthly basis. That means if we are going to deploy one T2 micro server, then we are going to use it, then we are allowed to use that server for free, because again, that will at max it is going to consume only 744 hours, even if it is left up and running 24/7, right? But if we deploy 2 servers, then that will simply mean that we are using it for 1440 hours. That means we have that here we get only 750 hours of free tier usage. That means if our usage goes beyond this limit, then we are going to get billed. Otherwise, otherwise, if we remain under this limitation, we are not going to bill a single penny. So let me share this link with you all, so you can also use this link as a reference. So I've shared the link with you all, guys. So here we can use this link as a reference. And here we can see the list of all the services available, and we can see the limitation. And that means what is the limitation of, for example, for DynamoDB, we can have 25 GB of storage offered in DynamoDB. For computation services, for Lightsail also we get 750 hours. For databases, we get 20 GB of storage, and we also get 750 hours of free RDS usage that we can use for free. And here we can see which all services are always free. Like we have the IAM servers, we have the services which are always free here. For example, for databases, for Lambda servers, we get 1 million free requests every month that we can use it for free. For same for SNS, same for KIME, for CloudWatch, for Cognito, for SES. So there are multiple services in different categories, and we can have a complete overview of what all services are available. And once we successfully sign up, then we can sign into our existing account. Let's do that. So let's say we sign into our dummy account. And once we successfully sign up, this is the dashboard that we are going to look at. Now remember, once we sign up for AWS, although we would be able to log into the dashboard, but the account may take up to 24 hours in order to get fully activated. That means even though we would be able to log into the dashboard, we may not be able to deploy some of the services because new accounts activation, it takes up to 24 hours. So it may happen within a few minutes, or it may take complete 24 hours in order for deploying these different solutions. Or we can say to have fully activated account with us. And here we can see the list of all the resources that we can start manipulating one by one. We can see the list of all the resources that we have the access to. So that's it, what we have as a part of the entire module that we have to cover for our introduction session. And so do you all have the access to this account yet, or you are about to create the account for yourself? Everyone, please give me a quick information, guys. Do you all have the access to the AWS account, or you are about to create one? Going to create one, already have it. Perfect. So even in case you don't have the access, you can use the account, we can use the portal to simply sign up, because every service that we are going to discuss, you need to practice this at your end if you're using your account. Correct? So you can sign up and have the access given to the AWS console. So first of all, we are going to cover now in terms of the entire flow of the services. First of all, we are going to cover the service for IAM. IAM refers to Identity and Access Management Service, where we are going to cover topics such as how we can create users, what are different IAM components available, like what exactly we mean by users, groups, roles, and policies, how they are structured, and how we can grant the access to how we can create users group first, and how we can define what kind of access the users who are going to be added in the group are going to have. What do we mean by roles? What exactly we mean by policies? So these all components are something that we are going to discuss step by step as we move further with the entire course. And then once we are done discussing these services, then we are going to see what are policies that are basically used for giving the access to multiple users, and what are the pre-configured policies available in AWS, and how we can create our own custom policies to give the access to our own account set. Then we are going to discuss on the components of how we can secure the entire account by specifying the MFA, by specifying the password policies, create how we can take care of the entire billing dashboard, how the billing happens, how we can get the entire detailed bill reports, how we can customize the entire bill, how we can customize the entire invoice, and how we can visualize it. And then we are going to see how exactly we can set the budget so that we can have a complete control on the amount of money that we are going to spend on accounts step by step. We have discussed on the entire architecture for AWS, that is how exactly it is divided in multiple regions and availability zones as well. So when we talk about AWS, again, it is completely divided into multiple regions and zones, and that exactly makes sure that the entire applications are available in almost different regions, so that we can reduce the latency, we can improve the availability of any application out there. So let's discuss on the concepts of regions and availability zones in terms of how AWS architecture is divided. So let's open up our notepad for having a quick clarity. Now, in terms of architecture followed by AWS, the entire AWS architecture is divided into two components. We have regions, and then we have zones. We have regions, and then we have zones. Okay, let's draw that out instead of just typing them down. So let's say this is the entire globe. This is entire globe, and we have one physical data center placed in Mumbai. We have one physical data center placed in Mumbai. Now, if we have global users, suppose this is a commercial website, and we have global users. So we have users coming in from North Virginia. We have users coming in from Johannesburg. We have users coming in from London, from Moscow, from Tokyo. We have users coming in from Sydney, from Singapore. So we have a global audience who is continuously using our website. And if all the, or now if suppose if we are getting multi-million requests on a daily basis and all the users, they are getting served only by a single server, or we can say a single data center, then that is going to create a massive problem, because that is going to first of all create a bottleneck situation where each and every request, that means the multi-million requests are being handled by a single data center only. So obviously this is going to create a high amount of latency. That means it is going to increase the response time. Plus, in case of failover, for example, suppose if this data center fails for any reason, or suppose it is not available for any reason, then the entire application is going to get down, which will mean loss in millions of dollars in terms of revenue and also in terms of brand image as well. Correct? So to solve this issue, what these cloud computing platforms had done, they have divided the entire structure into multiple regions and zones. So for example, in multiple regions and zones, that means for every user, for example, if we know that if we have a user base coming in from North Virginia, then we have deployed our application in a data center closer to North Virginia. So we have regions in North Virginia. We have now the users coming in from, suppose from Africa, although the current region for AWS has not been deployed in Africa, it is about to be, but still they will be served by a region deployed closer to them. Same way, users coming in from London, they can access the application from a region closer, from a copy of the application that has been deployed in a region closer to them. So for example, users coming in from London, from Frankfurt, from Paris, from Berlin. So again, they all, now, instead of going through the data center, going to the data center of Mumbai, it will be much feasible and much quicker to access the same application copy, the same data copy from the data center available close to them. Correct? So that's how the entire structure for AWS is divided. So we have different regions in different parts of the globe. So in total, there are 22 regions spread globally, and then we have to choose a region which is obviously closer to our users, which fits into our budgets. And that's how the entire concept for region is structured, so that the entire load on a single data center can be removed, and then we can increase the availability of the application, so that even though suppose if this region is not available for any reason, still the users can be shifted to the copy of the data or application deployed in some other regions. That's how it is structured in terms of regions for AWS. And this concept applies for every platform, be it AWS, be it Azure or GCP. They all have the same multi-region deployment. And apart from regions, we also have every region has multiple availability zones. Now, when we talk about availability zones, so just like when we say we are living in Illinois, we are living in California, so that means we are living in now the state. Every state also has cities, correct? When we say we are living in California, obviously we are residing in a city itself, correct? Same way, every region, they have multiple availability zones. They have multiple availability zones. We can say further segregation of how the data centers are divided. So every region, they have availability zones. Like we have now, some regions they have 3, some regions have 4, some regions have even 6 as well. Like for example, North Virginia has 6 zones in it, whereas Mumbai, Singapore, they have 3 regions in it, 3 zones in it. Same as Tokyo has 4 zones in it. So whenever we are choosing any region, obviously we have to also choose the zone in which we want to deploy the application. So for example, we have deployed our application in AZ1. Now AZ is referred as availability zones. These are the common abbreviations used in AWS for zones. So AZ refers to availability zones. And for example, if we deploy the application in one zone, and suppose if this zone is not available, then if we would have deployed the application in 2 zones, then the second zone would have been used for serving the request for the application. So we can improvise the availability and the redundancy of the application data. We can say one step further, and that's how it is structured in AWS. So the entire platform is divided into multiple regions and zones. So currently they are 22 regions, where 4 more regions are upcoming by the end of this year or next year. And then we have multiple zones. So in total, there are 66 zones available in total. And again, more are being deployed as we speak. That's how it is structured in terms of regions and zones. So are we all clear on the concept of regions and availability zones till this point? Please give me a quick information, everyone. Are we all clear on the concept of regions and availability zones? Perfect. Thank you for the confirmation, everyone. So let's erase this up. All right, so let's proceed. So now today, so as a part of the curriculum, so today we are going to discuss on the topic of computation. So let's get started. So today we are going to first of all focus on the components of EC2. EC2 as a virtual server that we can EC2 is basically Elastic Cloud Compute Service that is given by AWS, which will be used for deployment of virtual servers on this cloud computing platform. So I hope you all must be having the access to the AWS console by now. So this console that we had seen how we can use it. So I believe you all must be having the access to the console by now, guys. Please give me a quick information. Perfect. So great. So you all have signed up. Now let's get started. So for this module, we are going to focus on the pre-EC2 as and we are going to discuss what exactly is a virtual machine. We are going to discuss on the Intel processor generation, on the concept of regions and availability zones that we have discussed just now. And then we are going to discuss on instance types, the virtual CPU, the root device, AMIs. We are going to see the hands-on how EC2 is structured and how it is deployed. And then we are going to discuss on the pricing, on purchasing options, as we have 3 different purchasing options available, and the design pattern followed by EC2 as a part of our agenda for EC2 discussion. So first of all, before we start with the service, let's understand what exactly we mean by virtual machine. So virtual machines are basically like a virtual server that we can deploy on top of any platform. And now, to keep things simple, when we are trying to run any application, so obviously we need a server for it. For example, let's say a simple use case. Let's take the example for our own PC itself. Let's say we take the example for our own PC. If we have requirement of running any application, so obviously we need to have the access to our PC, correct? So we could upload application on top of this particular system because this system is acting like a server itself, as it has its CPU, it has the RAM, the processor, the graphic processing power. That means this is a complete server on which we can deploy the application and then we can get started, right? So, but again, this is going to be a physical device. This is going to be a physical device on which we can deploy the application, right? Or we can install the operating system and we can do everything that we can do with a system, with a server, correct? So either they have 2 options. Either we can configure this entire hardware, or if we want to run 2 different environments, for example, we want that on the same hardware, we also need to now, for example, one particular division should be running Windows and we need to create another server running, let's suppose, Linux operating system. So there are 2 options. Either we can purchase another PC, and then we can set up Linux on it, and then we can start performing our, or we can start running our services on top of Linux platform. We can do that, correct? Or we have another option that we then, using the same configuration, that means using the same hardware, we can create a virtual machine out of it. We can create a virtual server out of it, right? Where we, now suppose if this original machine has 16 GB of RAM, it has, let's suppose, 8 cores of CPU, and it has 100 GB of storage. So we can create a virtual machine out of it where we can allocate, now out of 16 GB in terms of total infrastructure, we can deploy 8 GB of RAM to this virtual server. We can deploy, let's suppose, 4 cores of RAM to the server, and we can allocate a size of, let's suppose 40 GB to this virtual server. So now this will be acting like a virtual PC where we can perform our own configuration, where we can install our own customized image. We can use our customized image in terms of having its own operating system files and different applications data, so that we can perform our operations accordingly. So that exactly is what we mean by the concept of virtual servers. So either we have, for processing powers, for our processing requests, either we can deploy the hardware, like we can say different hardware, or we can from the same hardware, we can create a virtual server out of it, so that whenever we want, we can even scrap it as well, because we don't have to worry about scrapping the hardware. We will be only scrapping the virtual system that we have created out of that given hardware. That exactly is what we mean by virtual machine. So are we clear on the concept of virtual machine? Or we can say virtual server, what exactly it is in simple layman terms? Everyone? Perfect. Thank you for confirming. So virtual machine, as we had discussed, so again, from a physical server, from a physical hardware, we can use the hypervisor. We can use any of the image that we want to use. For example, let's say we want to create a copy of this existing system that we have. So we can create an image out of it, and then we can choose that image in order to create any new, or we can say to use the same image on top of any other hardware. We can easily do that, correct? So you can choose accordingly what kind of image we want. And from the hypervisor, again, we can deploy any particular virtual machines running in their own configuration. That means we can choose the Windows, we can choose the Linux or the Mac. Mac are again still restrictive to the Mac hardware. But again, the concept remains same, because here we can simply emulate the computer having its own OS, RAM, CPU, computation capacity, where we can use it as a complete physical server. Now, virtual machines, as we know, again, they have their own configuration for RAM, for hard disk, and based on how exactly and how much of resources we are giving it the access to, they start using these resources accordingly. And then whenever we want, now the main advantage is whenever we need to scrap that content, or we can say the scrap the server, we can easily do that. We can easily scrap the content whenever we want. We don't have any kind of limitation. That means we cannot scrap it, or we cannot create beyond a certain number. As long as we have a requirement, we are ready to pay for it. We can create as many virtual servers as we want, depending upon and we can also choose what kind of configuration we want, what kind of processor, what kind of RAM we want. We can have a complete control on the configuration for even for the virtual server. And basically, hypervisor is a service that simply makes sure that the entire proper communication is maintained between the virtual servers and within the virtual machines and the exact resources and hardware, so that the maintenance, the deployment can be easily done by using these hypervisors. Next, we have regions and availability zones that we had discussed in the beginning. So the entire resources for AWS has been divided in multiple regions and availability zones. So here we have different regions divided, like we have US East, US West, then we have Seoul, Tokyo, Sao Paulo, we have Canada, EU, Singapore, Sydney. So there are multiple regions available, and again, they all have different availability zones. The same concept that we have discussed so far. So every region, they have multiple zones, and then whenever we are choosing any region, so obviously we are deploying the application in that particular availability zone itself. For example, each and every region can have multiple availability zones that we have discussed. And each and every region in AWS, they have been given a specific name, that the name for which I'll be sharing the entire list with you all, so that whenever we are deploying the solution, we can choose the region by the given name, and then we can start deployment of the servers one by one. Now, next we have the component of, before we see how exactly to deploy the EC2, let's discuss on the concept of AMI as well. So AMI refers to Amazon Machine Image, just like when we are creating an image out of our own system. So what we do, we create an image, and then we use services like we have the Oracle VirtualBox to create the image. And then if we already have the access to any image, then we can use that image to create any new virtual machine out of it, correct? So AMI refers to, the AMI contains information such as operating system, the entire architecture, storage for the root devices, as in what kind of instance store or EBS bar volume we are going to use, and what kind of virtualization type it is. It is going to be a we can say HVM or PV. And basically, in simple layman terms, for example, we have an application. For example, we are going to use, now in AMIs, we can choose multiple configurations available. So for example, here, if you have a requirement of deployment on top of Linux, we can choose a Linux AMI, or we can choose Windows as well. Again, in Linux, we have multiple distributions to choose from. For example, here we can choose Debian, CentOS, we can choose Fedora, we can choose the Ubuntu distribution, we can choose Red Hat or Kali Linux. We can choose any of the distributions. And same way for Windows, we have different images available for different configurations. That means we can use any of these given AMIs and as a base, and then we can start developing on top of it. Again, we also have the concept of marketplace as well. Let's say we are going to deploy a CMS-based website. Let's say we are going to use Joomla, WordPress, Magento. We want to have multiple AR/VR solutions already deployed. So these solutions are, that means these AMI contain the entire operating system, all the configuration for the softwares which have already been installed, and then we can use this entire AMI to launch any server which will have all the applications, data, and the configurations that has been done. And then we can use it as a base to start developing on top of it. So that exactly is the concept of the AMI. And AMI is a crucial component whenever we are trying to launch any EC2, or we can say any EC2 instance. So in AWS EC2 servers, these virtual servers are called as instance. So whenever we are trying to launch any instance by using the concept of EC2, we have to choose the AMI first, because without AMI, we cannot go ahead and create, we can say we can launch the instance. And AMI is something that we can either choose the pre-configured AMIs available by AWS, or if we have our own requirement, if we want to create our own AMIs, we have done the entire configuration. For example, we have launched an Ubuntu instance initially. And on this Ubuntu instance, suppose we have installed PHP server, we have installed MySQL servers, and we have deployed a complete PHP application. We have done the entire configuration on top of it, correct? Now, whatever changes we have done here, we want that whatever configuration we have done on this Ubuntu instance that we have chosen, now we want to use this entire changes, this entire customized AMI to use as a base for launching, suppose five more servers. So we can create a custom AMI out of it, and then we can choose this AMI for launching more number of servers. Let's say when we are going for auto scaling, where we want to have a copy of the same server being launched as a part of auto scaling. So we can choose any of these AMIs as well, depending upon the requirement. So we can either use any of the pre-configured AMIs, or we can choose to create our own AMIs as well. And how exactly these are done, that is something that we are going to discuss step by step as we move further with the course here. So before we move further, let's discuss on what exactly, we can say how exactly the entire instance is also triggered, because now in terms of now whenever we are launching any EC2 instance, there are multiple instance types that we can choose from. Now basically we have different instances categorized into compute, or we can say computation optimized instance, we can say memory optimized instance, storage optimized, and general purpose. So these are different types available in AWS. So now we also have multiple families that that has been structured in these different instance types. For example, we have general purpose, computation optimized, memory optimized, storage optimized, and these are families. Whatever we can see here, like M4, M5, M3, C5, C4, C3, these are families, we can say. When we have, let's say, when we have a requirement of deploying computation based instances, that means we want to launch in, suppose if we have a requirement of a large capacity, we can say a good computation power. For example, let's say when we had deployed a website where we are going to allow the users to upload their own videos and edit it in the browser itself. So obviously that particular application requires a good computation power. So we do need to choose the computation. So again, if our budget allows, then we have, again, obviously it is advisable to use any of the computation optimized instances. And again, they have multiple configurations available that we can choose from. Like we have X, XL, XX. So we have multiple configurations that we can choose from these different configurations. Same way, if we have a long running application that needs to optimize a good amount of memory, we have a high volume of traffic, then we can choose the memory optimized servers here. So we can choose any of the configuration that we want in terms of memory optimized. If we have large workloads, for example, if we are deploying any article solutions, then we can choose the storage optimized solution. Or if we are deploying a general based application like a general website, then we can use anyone from T2, M5, M4, M3, depending upon the configurations required. So for each and every requirement, we have different type of instances available that we have to choose from. first of all, let's see how exactly we can structure, and then we are going to discuss on these pointers step by step. So first of all, let's see how exactly we can set up our EC2 server by using the console that from which we have the access to. So let's go ahead and look at that. Now, once we are in a console, we have the option of going to the EC2 option. Now here we can choose our services, like we have all the services available. The easiest manner in which we can navigate to multiple services in AWS is using the service tab. So we can use the service tab to navigate to multiple resources. So we can search for any service we want to navigate to. For example, we want to navigate to EC2. Currently we are working on S3. Now we want to quickly navigate to any other service. Then the easiest manner is using the service tab available on the top section. So here we can search for any service, we can type the name, and whatever service is available with that name will be available for us. So here we have EC2 as a part of virtual server. So we can open this up. Now EC2 instance, now EC2 dashboard is like a region specific dashboard. So basically here we can see the region in which we are working in. So as we know, AWS has been divided in multiple regions and zones. So here we can see the list of region that we can switch to. So basically, this entire dashboard has been customized for the region that we have selected. For example, we can see currently we are in Mumbai region. That means currently we have one running instance, we have 15 KPIs, we have 2 volumes, one load balancer, and one Elastic IP is deployed here, and 37 security groups. So if we switch to some other regions, then we are going to see the resources deployed in that region only. That's why this is, as you can see here we can see the resources that has been deployed in this region only. So for suppose if we deployed 100 servers in Mumbai and currently we are switched to Singapore, then we won't be able to see a single server deployed in any other region. That's why we have to take care of the servers that we are using, because again, it may happen, especially for the beginners, to deploy the services in some other regions and simply forget about it. All right. And that's exactly is what we have to focus on. So here we can switch, suppose here we can switch to Mumbai, and different regions, they have different pricing, because the pricing is also not the same for every region in AWS. Why? Because we know that the infrastructure cost is different for different countries. The maintenance cost, the deployment cost is also going to be different countries, and that's why now the pricing, it doesn't mean that it is a drastic change in pricing, but again, the pricing is different for different regions, and that's why whenever we are deploying any solution, we have to make sure that we are choosing a region, first of all, which is closer to our end users, and which is also under budget, because again, obviously we don't want to surpass our budget as well, correct? And that exactly is what we have to take care of. And here, for example, here, if we switch back to Mumbai, we can see that now here we have the option of running instance. So we can see running instance, and currently we can see this entire instance is up and running for now. So in order to stop this instance, we can now let's start from scratch so that we can have a quick clarity of how the instances, how the resources are structured here. All right. Let's remove the delete protection. As you can see, it has been terminated. So now to launch any instance, we can click on this option which says launch instance. And here we can see the launching instance is a 7-step process. First of all, as we had discussed, we have to choose the AMI. So again, we can see these are the pre-configured AMIs available. First of all, we have the most popular AMIs available here. Like we can have Linux 2, we have Red Hat, SUSE, Ubuntu, Microsoft servers. Then we can choose any of these pre-configured AMIs. Or if you want to see the entire list of all the community AMIs available, community AMIs, as we know, it simply is the license-free AMIs. That means here we don't have to worry about setting up the licensing here. So we can choose from different configurations required that is available. For example, if you have a requirement of deploying CentOS, Debian, Fedora, Gentoo, OpenSUSE, we can choose any of these configuration as per the requirement. For example, suppose here we want to launch Ubuntu. Again, we can see we have different configurations for Ubuntu available. Ubuntu for Xenial, for deep learning. Again, for deep learning, we have different configurations available. That means these already have certain pre-configured components already configured that we don't have to worry about configuring at our own end, right? We can choose any of these configurations that as exactly as per our requirement. Same way for Windows. Again, for Windows, we have different configurations for Windows servers available. And then we have the component of the marketplace. So marketplace contains multiple applications. Now on top of the operating system, we also get multiple applications also pre-configured. So here we have the configurations of multiple servers available. Like we can, so for example, suppose if we want to launch any CRM based products, we want to launch any content management products. For example, suppose if for content management, we can see we have multiple configurations for multiple CMS available out there. So we can choose any of these configured CMS and we can choose accordingly. For example, if we want to deploy any Magento based instance, we already have a Magento AMI available. If we want to deploy any WordPress based AMIs, where the entire configuration for PHP servers, MySQL servers, MySQL databases, the entire installation for WordPress, these all things are already pre-configured. So we have two options. Either we can choose the base Ubuntu AMI and we can perform all the operations at our own end, right? Or we can choose a pre-configured AMI, which already contains the entire setup, and then we can choose that AMI to start developing on top of it. We have both the options available. All right. So it all comes down to our own preference and then we can deploy it accordingly. So first of all, are we clear on the concept of AMIs? Please give me a quick information, everyone, before we proceed further with the instance type. Perfect. Thank you for confirming. Ashok, so HVM, PV. So Ashok, these two are different types of virtualization. Like we have PV, PV refers to para virtual, and then we have HVM, HVM refers to hardware virtual machine, like we have hypervisors, right? So these two are different type of virtualization that we can choose from. And again, basically the main difference between them is the way they treat the entire hardware. That is how the hardware is interpreted by these two systems. That exactly we mean by these two different type of virtualization that we are going to discuss step by step as we move further. Perfect. Thank you for confirming. So here we can choose any of the, for example, let's say if we want to choose Ubuntu as a part of our default AMI, we can choose Ubuntu. Then we have different instance type that we discussed. So we have different type of instances available based on our own requirement. For example, we want to go for general purpose, computation optimized, GPU optimized, memory optimized, storage optimized, then we can choose the entire configurations. And even for a single family, for example, here we can see here we have family for T2. Again, in T2, we have further configurations available, like for small, medium, large, X large, 2X large, more like a clothing, more like a clothing line. But again, that's how it is structured here. So here we can choose from the configurations in terms of the number of cores of CPU. And here we can see the memory available. Again, we are going to discuss on the storage tab step by step. So basically here we have the EBS backed volumes and then we can choose the configurations available. And for example, suppose now to see the entire detailed list of what all different instance types are available, let me share a document from AWS itself so you can use it as a reference. Let me share that with you just a moment. So we can refer to this entire documentation to see the list of all the available instances available depending upon the family. So we can see here we have the details for memory optimized, for computation optimized, along with the exact configuration of the hardware used in these different AMIs. For example, we want to see, okay, what kind of processor is being used for computation optimized instances. Then we can see the entire list. For example, for computation optimized, we can see we have family for C5, C5A, C5N. For example, in C5, we can see the Intel Xenon scalable processors Cascade Lake are being used with a frequency of 3.6 gigahertz, which can be scaled up to 3.9 gigahertz. And for C5 instance, again, they all have, now we can see the entire configuration in terms of the number of cores of CPU available, the like for example, it requires the HVM or it is based on PV. We can see how much of RAM we can scale it to. So you can see the entire configuration exactly as per the requirement. So for example, for memory optimized, we can see here we can get 768 gigs of memory if we have that much of requirement in terms of memories requirement. So here we can, again, for every family we have further classification based on how many cores and how much of exact RAM we need in terms of the performance. So depending upon the exact requirement, we can choose the correct configuration type accordingly. So let me share this with you all. And again, in terms of certification point of view, we don't have to memorize each and every configuration that is available. We only need to know, okay, which family is for memory optimized, for example, R5, or for which family is for which category and where exactly they are going to be used. So let me share this link with you all so you can use it as a reference. Here you go. Now, once we have chosen, for example, now when we are using the free tier account, we get only one instance type that we can deploy as a part of a free tier access. That is T2 micro. If we deploy any other family, the moment we deploy it, we are going to get billed accordingly. And then if we want to stay in a free tier access, then we have to choose only T2 micro, because in T2 micro, we get 750 hours of free tier usage, but only for one server. That means one server will be up and running. Suppose if we deploy one server and that server is up and running for the complete 24 hours, then at max we can consume just 754 or 744 hours in a given month, even for 31 days, right? But if we deploy more than one server, then we are going to pay for that before going beyond the 750 hours of usage given by free tier access in AWS. Now, once we have configured that, then we can configure instance detail. Now, in instance detail configuration, we have multiple configurations that we have to take care of. So here we can see the entire number of instances available, like we have one. Then we have the number of networks. So for example, we can choose how many servers we want to launch here. For example, we want to launch one server, 5 servers, 10 servers, 50 servers. So in default account that we sign up for AWS, we have a limitation of deploying just 100 servers. So again, these whatever limit we see in a default account, these all are soft limits. That means whenever we have a requirement, we can ask for those limits to be uplifted so that we can increase the number of resources that we are going to deploy here. And we can choose a number of instances. In terms of purchasing option, we have 3 options available. We can go for spot instance, on demand, spot, and then we have results. So again, what exactly are these, how they are structured? We are going to discuss that part step by step. And then we can choose the network in which we want to deploy them. Network as in, if you have, let's suppose if we are deploying multi-tier architecture. For example, we are deploying multi-tier architecture. We have the web servers, we have the application servers, and then we have the databases. Now, so for example, web servers needs to have the full access to the internet. Then we can deploy them in the public subnet. We can deploy them in the public subnet where we can attach them to the internet gateway for our full access. Application servers and databases, they need to be kept private. So we can deploy them in the private subnet where we can attach them to the NAT gateways for our control access to the internet. And further, we can define the entire config, we can say access level by using the components of ACL and also for different other components. So how the entire, now these all components, how the entire architecture is configured, how we can create our own customized network by using the component of VPC. That is something that we are going to discuss in our further modules. So you can choose in which network, in which zone, and how exactly we want to assign the IPs here. We can choose the configuration as per the requirement. So we can choose now. So for now, we can keep it to the default account that we already have the access to. And then we can choose now here we can choose a placement group. So placement group is basically like a collection. Let's say we have deployed 10 different servers. So obviously we don't, when we want to stop those 10 servers, when we want to perform any activity on those servers collectively. So obviously we don't want to run we can say run the command on each and every individual instance. So we can place them in a single group so that whatever we need to perform, we can run the activity in a single go itself as a part of placement group. And same way we have roles. So roles are something that we are going to discuss. So we can, for example, we want that this instance should be having the access to the RDS so that this server can read and write data from the database that we are deployed in RDS. So we can create a role granting the access to this server to access the content available in the other role, right? So we can see the entire configuration here, and then we can choose what kind of, let's say we configure, okay, if we press the power key, then it should stop it or it should simply terminate it. So when we stop any instance, that means we can restart it. But if we terminate any instance, that we are simply killing away the instance, right? Then we can choose the monitoring service. Monitoring as in monitoring is available by the service name as CloudWatch that we are going to discuss in our further modules where we can monitor each and every metrics available in this instance accordingly. And then we have tenancies. So tenancy is basically offered as a part of shared and dedicated tenancy type. So when we talk about tenancy, let's say if we talk about tenancy here, so tenancy is basically of two types. Let's erase this up. Now tenancy is basically of two types. We have shared and then we have dedicated. We have shared and dedicated. So shared is, for example, we have deployed a server and this server suppose is having 1 core of CPU and 1 GB of RAM and 1 GB of RAM. Now in shared server, suppose in the same server, there are multiple applications. Now this server is being used by multiple vendors for deploying all their multiple applications, right? Suppose they have multiple applications deployed here, then these are being used. Then the same server having the same capacity is being shared by multiple vendors by multiple applications. So for example, if we deploy 10 different applications here by 10 different vendors, so obviously these 10 applications are going to have, we can say, less perform. These are going to not perform really well because they all are sharing the same resource, correct? But in dedicated, if we have any dedicated instance, so even if we have the same configuration as 1 core of CPU and 1 GB of RAM, 1 core of CPU and 1 GB of RAM, we can see now if even if we deploy a single application, then this single application is going to perform really well even on the same configuration because now the entire resource is being used by only a single application here, not by multiple. And that is at least what we offer, that we have as a part of tenancy available in AWS. So are we all clear on the concept for tenancy till this point? Please give me a quick information, everyone. All right, so now to get started, now to see the list of all the instances that we have already deployed, we can go to instance. And in here, we can click on launch instance to launch a new instance for us, where we can see the list of all the available AMIs. We can see how many AMIs are available. We have discussed there are multiple community AMIs, like we can choose the AMIs from Debian, CentOS, Fedora, Red Hat. For whatever instance that we want to deploy, we can choose accordingly, depending upon the requirement. And once we have specified that, then we can, now for example, let's say here we want to start with Ubuntu. Let's say we want to start with the Ubuntu AMI, we can choose Ubuntu. And then we can choose any type of the configurations for in terms of the instance type, and then we can be specific on any particular category. For example, now in order to keep ourselves in the free tier account, we have to use the T2 Micro. We can click on configure instance detail, and here we have also discussed on what exactly is we can decide how many servers we want to launch, what in which network we have to deploy it, in especially in terms of multi-tier architecture. We have discussed this part. Then we had discussed on placement group and also on the IAM roles. So role is something that we are going to discuss in detail once we start our discussion on IAM service, that is Identity and Access Management Service. And then we are going to look at how we can define multiple users, groups, how we can create custom policies, and how we can attach roles for different services. And then we had discussed on the component of tenancy as well. So we have two types of tenancies available, shared and dedicated. So are we all clear till this point on whatever we have discussed so far? Please give me a quick information, guys. Or in case you have any questions on whatever we have discussed till the third step, you can go ahead and ask. So are we all clear? Please give me a quick information, guys. Are we all clear till this point? On the AMIs, instance types, and the configuration? Perfect. Thank you for confirming, everyone. Now, once we have chosen the entire configuration, now we have the option of choosing storage. Now, just like every PC needs to have an internal hard disk. Let's say if we talk about any particular PC here, let's say we talk about any particular PC, right? So just like we know that every PC needs an internal hard disk in order to operate properly, correct? Same way, every storage, now for example, every server also needs an internal storage, because without this internal hard disk, this processor will not work at all. Same way, every EC2 instance needs to have a volume defined here, and again the storage is defined as an EBS. So here we could refer the storage capacity as EBS. EBS refers to Elastic Block Store. So for every server, we have a volume attached, and then this volume, now we can attach multiple volumes. We can attach, in a single PC, we can attach multiple hard disks, correct? We can attach multiple internal hard disks. Same way, in a given server, if you want, we can attach multiple volumes as well. So one volume can be the root volume, and the other ones can be additional volumes, which we can use for storage of our database or for any particular additional data set. We can define that. And we just like we can choose different configuration even in our internal PC. For example, for keeping the operating system files and the application files, we can use a high performance disk like we have SSDs as a root volume. Whereas for all the other documents and files, we can use we can say a hard disk, because again we know that if we are focusing on those application files which needs to be processed quickly, then obviously we need to store them in a high performance drive, whereas the normal documents and files and folders that we do not wish to use frequently, then we can store them in a low cost sequential based drive, that is hard disk. And same way we have different configurations available for EC2 servers as well by the name of EBS volumes. So basically, when we launch any server, we have to choose a root volume. That means we have to choose what kind of volume we are going to create and with what configuration. Now we can change the configuration. We can add more number of volumes even after creation of this instance. We can do that. So for example, here we define the root volume in device. Now here where we are going to mount it as a part, since we are choosing the Ubuntu image, and snapshots are basically like a backup. So these are called incremental backups, and how they are structured, we will be discussing this part in detail as we move further. And then we can define the size. So in EBS volume, we can define a size between 1 GB and we can scale it up to 16 TB in size. That means a single volume can be minimum 1 GB to 16 TB in size. And then we have to choose the volume type. So basically we have 4 types of volume available here. We have general purpose, provision IOPS, then magnetic, and then we have another one as cold hard disk, or we have another one as throughput optimized. So in general, we have 5 type of volume types available. So general purpose are basically, now we are going to discuss this part once we start our discussion on EBS step by step. But for now, we can have a quick understanding that general purpose are basically used for, we can say, for those applications where we need to maintain, where we don't need a high number of IOPS. That means all the application files, the root devices. For them, we can maintain the IOPS. For that use case, we can maintain the IOPS between 100 and 3000. So basically, now when we talk about although we are going to discuss this part in detail, but let's have a quick understanding of what exactly is IOPS and throughput. Because when we refer to any drives, we have to understand these two concepts. Now we have components such as IOPS, and we have another concept called as throughput. So first of all, IOPS is, when we say IOPS, it simply means input, output per second. Input, output per second. That means here it defines the number of read and write operations that we are allowing for a given hard disk. That means, for example, if we say, okay, this and suppose this hard disk, this volume is going to have 3000 IOPS. This can give us 3000 IOPS. That means this will allow us to perform 3000 read and write operations. Now it can be 2000 read operations and 1000 write operations. So in total, this can provide us with 3000 read and write operations on a given second, on a per second basis. And then we have something called as throughput. Then we have something called as throughput. So throughput is basically the bandwidth. For example, when we say we have a bandwidth, suppose we have a throughput of 500 MB per second. That means we are allowing the 500 MB of data to flow in a given per second basis. And again, this can be for any operation. So here we don't care about the number of operations. We focus on the amount of data being transferred on a per second basis. And that is what we mean by throughput. And when we launch any particular volumes, we have to take care, depending upon the requirement, we have to take care of the IOPS and the throughput. Basically two types. The hard disk, the volume that we are going to discuss, basically there are two types available. Like we have SSD based volumes and we have HDD based volumes as well. So SSD based volumes are basically useful for random access, whereas hard disks, again, they are useful for sequential access. So when we have a requirement, when we are hosting our operating system files, when we are hosting application files, so obviously we want these files to be accessed in a, we can say, in the quickest time possible, right? So here we can choose SSD, and again in SSD we have two types. In one, in general purpose, we can maintain, we can get the IOS from in a range of 300 to 3000. We can get the IOS in a range of 300 till 3000. That means based on the requirement, based on the request coming in, it will scale up and scale down the IOPS between 300 and 3000. Whereas we also have something called as provision IOPS. So basically in provision IOPS, we can scale up the entire IOPS from 100 till 64,000 input output operations happening per second. We can get 64,000 IOPS in the provision IOPS. We can say the volume type available in EBS. So basically, these are useful for data-centric application. For example, when we are storing databases, when we are storing an instance of Oracle or MySQL or MyDB in that particular instance, or we can say that particular volume, and we want to maintain a consistent performance. We want to maintain a consistent IOPS of 5,000, 300, 5,000, 10,000, 12,000, and we can scale it up to 64,000 input-output operations happening per second as a part of the provision IOPS that we are going to discuss. So are we clear till this point, everyone, on the concept of IOPS and throughput? Please give me a quick information, everyone. Are we all clear till this point? Perfect. Thank you for confirming. So let's erase this up. All right, so now let's move back. So if you want to add more volume, we can add more volume as well. We can choose the device type, where exactly we want to mount, what are the available device we can say, because in Linux we have to mount based on these different available devices we can choose. And then we can define the volume type like we discussed. We have general purpose, provision, cold, throughput, and magnetic. These are something that we are going to discuss in detail as we move further step by step. And then once we are done, we can again, delete on termination is when we delete the instance. If we don't want the volume to be deleted, then we can simply uncheck this box, or if we want the volume to be also deleted, then we can keep the box checked. That means along with the instance, this entire volume is also going to be killed. That means suppose if we uncheck this option here, that means even after we delete the instance, but now after a while we want to we can say we want to use this volume with any other instance, then we can do that if we do not delete the volume upon termination of the instance. So we can keep it a check. Let's say we do not launch any other volumes for now, we can launch it later. And here we can click on review and launch. Now tags. Tags are important concept for every resource. So tag is something common for every resource, every service that we are going to use on AWS. Now to understand the concept of tags, let's have a quick clarity on that. So let's say we open up any e-commerce stores. Let's say we open up any e-commerce store here. And let's pick any category. Let's say we pick the category for casual shoes. Or let's say we move to sports shoes. Now in this category for sports shoes, we can see there are 10,833 items available, right? So if we are looking for a pair of shoes, and again, we have multiple filters available, like we have multiple tags available for brand, for price, color, discount range, the archetype, bundles, cushioning, clits, fastening, material, cushion type, outsole type. So we have multiple tags, we have multiple filters, as in multiple tags available. So if we are looking for a pair of shoes for us, will it be easier for us to find the exact pair of shoes we want without using these tags or filters? Will it be easier for us, everyone? If there were no tags available here, if there was there were no filters, will it be easier? Obviously not, correct? Although it is not impossible, we can find, given time and given patience, we can find the pair of shoes that we want. But again, it is not going to be easier task, correct? Same concept applies to the concept of tags here. Because again, now, if we have multiple resources deployed, for example, we have deployed 50 different resources, 50 different instances. And when we deploy any application, on AWS, obviously that application is going to have multiple components. For example, in EC2, we have, for example, for application, we had deployed EC2. And in EC2, suppose there are 50 different instances that we deployed. And our application that we have deployed here, it is deployed only on 10 instances, correct? And we have also deployed, suppose, S3 bucket for application. We have also deployed the CloudWatch service as well. We have also deployed the RDS-based instance and suppose 10 other services, 10 other resources as a part of our entire application. And now each and every service will have multiple deployments for some other applications as well, correct? Now, if we want to see the list of all the resources that we have deployed for our application, so how we can do that? There needs to be something common in every resource that we deployed for this application, correct? Suppose we have application 2, we have application 1. So if we want to segregate them, then for that purpose, we have to use tags. So tag will be common. For example, if you're deploying something for application, this tag is going to be common for every resource, correct? So that if you want to see the list of all the resources that is up and running for the given application, we can see that by using tags. If you want to see the billing for the entire application, for all the resources that is being used by application 1, and we want to see the separate billing for application 1 as well, for application 1 and application 2, then we can simply filter out all the resources by using the component of tags. If we want to perform the software updates and patches on the given resources for a given application, we can filter them out by using tags. So tags are crucial component for every resource that we deploy when we are going for enterprise solutions out there. And that's why here we can define the key value pair as a part of tags. So for example, let's say here we want to add a key value pair. For example, this is going to be, we can define type. So if this is going to be a web server, we can define the type as web server. We can add another type. Suppose this is going to be a part of which project? This is going to be a part of project, let's say healthcare project, or suppose healthcare. Suppose we are building different solutions for healthcare, for banking, then we can simply define the project type here. So that if we want, we can filter out the entire group of resources by using this common tag. So are we clear on the concept of tags? Please give me a quick information, guys. Everyone, are we clear on the concept of tags? Wonderful. So once we have configured tags, then we have to define security groups. So security groups is basically like a firewall to the instance. So when we say firewall, here we can have a complete control of what kind of access we are going to give to this particular server that we are trying to launch here. So here we can choose from multiple available protocols. That means here we have the complete support for all the TCP protocols, UDP protocols, ICMP, POP3, IMAP, LDAP, HTTP, HTTPS, Redshift. So again, these are different protocols for allowing the access for this instance to connect with the other instance, or you can say another service here. So these are multiple protocols that we have that we can give the access to. For example, we want to connect to this instance via SSH for taking care for manipulating this entire instance in terms of background processes, correct? So then we can have to give the access to SSH, and then we can define the port range as 22. Then we can define the source as in that means the traffic coming in from which particular source should be allowed. So when we define it as 0.0.00, that means we are allowing the traffic from anywhere. This is referred as a public source, right? And then if we want to keep it through my IP, that means if we want to give the access to our own IP address, then we can choose our own IP address. Suppose our own, that means only we will be allowed to have the access to this instance when we try to access from the given IP, right? Or we can keep it to anywhere. Same way, let's suppose if we are trying to deploy any web-based application, for example, we are deploying any website. So obviously websites are meant to be opened up in the browser, correct? So for example, if we define this as example.com, so obviously this is going to need the access to the HTTP or HTTPS server in case we have the SSL certificate installed, correct? So for that, we have to go ahead and use the component of HTTP protocol. So here we can define HTTP. For HTTP is basically answered on port 80, and then we can define the custom. That means since we are going to host a public application, obviously we want the access for anyone coming from anywhere, correct? Same way, if we have an SSL is already installed for this domain, so obviously unless we give the access to HTTPS, that SSL certificate is not going to be answered. Why? Suppose for a domain we have already installed the entire SSL, but here we haven't given the access to HTTPS protocol. That means here the HTTPS traffic will not be answered by the given instance because we would have not have mentioned HTTPS here, correct? So for whatever port range, whatever protocol we want to define, that we can define as a part of security group, which acts like a firewall for the given instance. So for example, if we have deployed a complete file structure, for example, we deploy a complete file structure here, then we can define the NFS protocol, and then we can connect that particular file structure using this NFS protocol as well. So depending upon the use case or requirement, we can choose the correct protocol, we can define the entire source, and then we can add it. So are we clear on this point, everyone, on what exactly we mean by security groups? Everyone? Perfect. So once we define these security groups, then we can review, and now here we can click on review and launch, and where we can review each and every setting that we have configured for the given instance. Once we are done, we can click on launch. Now, once we click on launch, now obviously this instance, we don't want anyone coming from anywhere. They should have the access to the backend, correct? Because backend needs to be secured. So that's why here, when we are launching the instance, we can choose the authentication type. That means we want the users to log in. For example, we have the entire developers team. Now we want them to log into this instance via a password or via a key, that we can choose a key. So now if we are using a key here, we can choose the same key for multiple servers. For example, we deploy 50 servers. And then we can choose the same key pair for deployment of those 50 servers. And if we want to create a new key pair, we can click on create a new key pair. So here we can find the key pair name. Let's name it as June 11 to avoid confusion. We can click on download key pair. Now, anyone who is trying to access the given instance via SSH, they will require to use this key, because even though they know the correct IP address, the username, everything, but still if they do not use this key, they will not be allowed to have the access. So here we can choose June 11. Now, once we have the access to this key pair, so for example, if we are deploying the server for our developers to manage, then we have to give them the access to this key pair, then only they can get started. All right. So once we define this key pair, then we can click on launch instance, and we have to make sure we are saving this key pair for us, because if we do not save this key pair, we will not be able to log in to this particular instance. And again, if we lost it, then suppose if this key is lost, if we lose it, then obviously we have to contact the entire support team, or we can say we have to go back to the main instance, and then we have to reset the key by by generating a new key, and then uploading that key in that given location that I'll be showcasing you all towards the end. That means as we proceed further step by step with the entire course. So once we have the key pair with us, then we can click on launch instance, and based on the configuration that we have chosen, this is going to launch the instance. And launching the instance takes almost, we can say, a couple of minutes. So you can see currently it is still being deployed, and unless the entire status has been checked, this is not going to be deployed. And as a good practice, it is always advisable to name the instance, because if we have multiple instances, then instead of opening up the same instance again and again, we can easily identify what this instance is all about by giving them a proper name. So are we clear till this point on how we can launch the entire instance? Till this point, please give me a quick information, guys. And Anil, so can you please explain the public and private key? So this is a simple private key, Anil. And once we get the entire access to this key here, then we are going to use this key in order to get connected. All right. And how to connect, we are going to discuss that part step by step in next few minutes. Perfect. Thank you for the confirmation. So now once we deploy the instance in here, now this is going to initiate. Unless we have the entire status check updated, we won't be able to see this entire instance up and running. So when we deploy the instance, now we can see the tab here for description, where we can find the entire description for the launch instance. So here we can see the type of instance that we deployed, the public IP, this is public IP, and DNS is automatically assigned to the instance once we deploy this in a current VPC. So since we are choosing the default network, the default VPC given by AWS, that means here we are going to get the default. That means pre-configured, or you can say the IP address is already given by from the pool of IP addresses available from AWS.
Yeah, I have one question. I just want to know, like, we need to use the default IP generated by system, or is there any possible option that we can use the custom IP?
So when we are trying now, this is for the public facing application. Obviously, this is an entire public IP which is already given by the pool of addresses from AWS. So this is something that is automatically generated. But if we want to have a complete control on the private IPs that we are going to create for the entire cluster, then we can do that by the help of VPCs. We can create our own custom VPC. We can define the entire access, and then we can have complete control on the IP address allocation as well.
Like
Something that we are going to discuss.
like
Mhm.
by creating virtual private cloud, right?
Absolutely. So we can create an entire VPC, and again, we can have complete control over that. That is something that we're going to discuss in our VPC module.
Okay, thanks.
No problem. All right. So here we can see the entire VPC. Now, currently, this instance has been launched now, but this instance has no component configured yet. Correct. So that means if we open this up as this public IP and we use this in the browser, we won't be able to see anything, because we haven't installed any server yet. There is no application file deployed yet, correct? That means we are not going to see anything configured until as we configure a server, we install at least one Apache server, or we have some kind of we can say web files to render in the browser, correct? That's why we are not able to see anything here. So let's do that. Let's do one thing. Let's try to connect to this particular instance. So there are multiple ways of connecting to this instance via any SSH client. So we can, one of the older ways we had PuTTY. So are you aware of PuTTY? So in case you have been working in the development environment, you may be aware of PuTTY. So we can connect via PuTTY as well in order to they get connected. So PuTTY is also one of the popular SSH based client that we use for getting connected to PuTTY. So in case you have not used PuTTY, let me share the entire download link with you all that we can use to, not this one, yes. So if we are trying to connect via PuTTY, now PuTTY is basically Windows specific, so we can download PuTTY based on the system type, as in 32-bit or 64-bit. Right now, every system is currently 64-bit itself. So we can choose a configuration. First of all, when we are trying to use PuTTY for getting connected to this EC2 instance, we need two things. We need to have the access to PuTTY, and we also need to have the access of puttygen.exe. Because why puttygen? Because the key file that we have downloaded is in .pem file, and PuTTY accepts the key files in the format of .ppk, PuTTY private key file. So using puttygen, we can convert this PM into .ppk, and then we can get connected. Or we have we have many other platforms available, like we also can use. First of all, let me share this link with you all, so you can use it as a reference. And then we have multiple other components available, like we have Mobexterm. So this is also a really good platform for getting connected, where it offers multiple connection types. That means here we can choose to get connected by SSH, RDP, we can use SFTP, we can use the serial, XDMC, RSH, shell-based scripting. So here we can have multiple protocols that we can get connected to. So, and here we don't need to convert our PM file into .ppk. We can use a PM file directly. So this is also something that we can refer to keep our work much simpler. Now let's open this up so that we can use this to get connected. Now, if we are trying to use this Mobexterm to get connected, we have to first of all click on this option which says session, and here we have to define SSH. So under SSH, we have to define the entire IP address for that. Means what is the IP that we are going to connect to. Now here we can choose the entire configuration for SSH. Now in SSH, we can define the remote host. Now in remote host, we can enter either the public DNS or we can enter the IP address. We can give it the IP address here. And then we have to specify our username. So we have default usernames for different AMIs that we deploy on top of AWS. So currently we have chosen the AMI for Ubuntu. That's why here the default name here is going to be Ubuntu itself. So for different AMIs, we have different usernames available. So for example, for Ubuntu, we have Ubuntu. Now, although we can create multiple users for that particular instance, same way for Windows. For Windows, we have to use we can use multiple names. But when we are trying to log in, we have to use the default username. So here we can refer to this entire documentation here, where we can get the default username for Linux 2. For example, if we are trying to deploy Linux 2 AMI, then the default username that we have to use while connecting is going to be EC2-user. Same way for CentOS, it is going to be CentOS. For Debian AMI, it is going to be admin or root. For Fedora, it is going to be EC2-user or Fedora. For Red Archie, for AMI, it is going to be EC2-user or root. For SUSE, it is going to be root itself. For Ubuntu, it is going to be Ubuntu. And for Windows, it is going to be the root user. So let me share this with you all so you can use it as a reference as well. There you go. So since we deployed Ubuntu instance, so here we are going to use Ubuntu as our default username. So we can choose the Ubuntu AMI. So here we can choose the default name as Ubuntu, and if you want, we can create multiple other users as well. Same as Windows. If you want, we can create multiple user accounts and they can log into their own account itself. So same way we can also do for these cloud instance. Now, once we define the username, then we also have to use a key file that we have downloaded. And the port will remain same because we are going to get connected by SSH that has been defined on port 22. And then we have to, now for using the key file, we have to go to advanced SSH settings. So here we can go to advanced SSH settings. And here we have to configure the AMI that we are going configure the key that we are going to use. So the key file is going to be the PM file that we have downloaded. So let's point this to our key file. So the key file was named as June 11. So here we have June11.pm and open. So if the credentials are correct, if the username, the IP address, and the key file is correct, then if we click on OK, we would be able to gain the access to the instance. So as you can see here, the entire credentials were correct. So now we have successfully connected to the instance, and now we can start manipulating it. So for example, if you this is same like since this is running on Ubuntu, so we can perform the same Ubuntu command, the same Linux command that we may be aware of. Again, if you're not familiar with Ubuntu platform as of now, so not to worry. Again, at the end we are here to become we are here to become architects, not developers. But again, it is always nice to have a knowledge of how the shell scripting works. And to see the list of other common Ubuntu commands, let me share a list of common Ubuntu commands that we can use in order to start interpreting the entire instance. So you can use this link as a reference to have a quick understanding of the common Ubuntu commands in case we have never used or when we have never used any languages so far. So now to start interpretation, now first of all, here we can clear the screen. And now let's say we want, now in this instance, currently we are not seeing anything in the browser, correct? Now we want to see what exactly, if we open this up in the browser, we should be able to see at least the Apache server, correct? So for doing that, we have to install Apache server. So now let's say if you want to install Apache server, we can come back. First of all, let's resync all the services by using a common command such as sudo. Then we will specify apt-get update. So this is going to resync all the services that we has already been installed or that is available in this instance. So as it is done, now we can use, now for installation, we can use, let's first of all clear the screen. Now for installation purpose, we can use the command such as sudo. Now why we use sudo? Sudo is basically for giving the command the administrator privileges. Just like when we open up any program in Windows by right clicking on it and then we choose, okay, open this as administrator. Correct. So same way we are giving the administrator privileges itself. For example, in Windows, when we open up any command, for example, we are going to use open this program. So here we can click on right click on it, and here we have run as administrator. So this is going to run this entire program with the administrator privileges. Same concept applies to the command line here. So using sudo, we give the administrator privileges, and then we can use the apt-get library, and then we can use the command as install. And then we have to name the package that we are going to install, Apache 2. So here we can press enter. We can keep it a Y. So now this is going to install Apache 2 server on our instance. That means after successful installation of this entire Apache 2 server, we would be able to see the home page of Apache 2 being opened up in the browser for the given IP address. If we go back, here, now on the same instance, since we have successfully installed Apache 2 server, we are able to see the Apache 2 server homepage being opened up. And now we can upload any file. For example, here we can upload static file in the var www folder, and then we can see that file also being opened up in the. So are we all clear on how we can get connected to the instance that we had deployed just now and whatever we have done so far? Ashok, Ruswan, Arun, Anil, Sunil. Perfect. Thank you for confirmation, everyone. Ristan, can you show the example for Windows? Sure, Ristan. So basically, in our subsequent session, we are going to also see the example for Windows as well. So we can choose a Windows AMI because in Windows, for Windows, we are going to use the RDP as a remote desktop connection. And then we're using the RDP, we can get connected. So in our subsequent session, we are also going to see the example for how we can install Windows, how we can install them in different networks, and how if you're looking to get to connect multiple Windows instances together, we are going to discuss that part as well, step by step. So for Windows, again, we only have to choose the Windows AMI. For example, here we can choose now in community as well. For example, we want to deploy a Windows-based server. Let's say here we want to deploy the full base for Windows Server. We can choose this AMI. We can choose the instance type. We can choose the configuration, as in what exactly configuration we need. Same way we had discussed for every other instance type. And then here in terms of metadata, we can define the entire token response, hop limit. We can define the entire capacity reservation. We can choose to deploy the entire configuration in terms of storage. And then we can add tags. We can define security groups. For now, here we can see, now here we are going to get connected via the RDP, not the SSH line. So like we had discussed, that we can see also in our Mobix term, we can get, now we're using this platform, we can also get connected via the RDP protocols as well, correct? And then we can define the protocol here. If you want to keep it specific to only us, that means we should be only allowed to gain the access, no, not anyone. Then we can choose it to our own IP, or if you want to give the access to a specific IP address, we can give it that. Here we can click on review and launch. We can do each and every parameters here, and then we can choose a key pair. For example, what kind of key pair we are going to use for getting the access. For example, here we can choose a key pair. Now the same key pair can be used for multiple accounts. The same key pair can be used for multiple accounts as well. So for example, if we now why we use the same key pair? If we have deployed the same application, we have deployed a cluster of 50 servers. And obviously we don't want to use different key pairs for different servers for the same application, correct? Then we can choose the same key pair. And if we want to are deploying multiple applications in different servers, then obviously we are going to require different key pairs in that. And again, in case you are using your free tier account, to make sure that you're not getting billed. So obviously it is always advisable to simply terminate the instance once we are done working on it. Because if we keep the server up and running, so either we can stop. So when we stop the instance, we can restart them again and again. For example, if we stop any instance at a later point of time, we can restart it. But if we terminate any instance, that means that instance is now fully terminated. That means now if we terminate any instance, that means we cannot retrieve it, the instances. And then we are going to look at how we can get connected by RDP protocol as well. We can look at that. All right, so as we move further, so now we are going now, as we move further, now we are going to discuss on the entire concept for different billing concepts. That means how the entire on-demand provisioning and spot instance work. Then we are going to discuss on the concept of volumes, how we can declare, how we can how the different volumes are configured in terms of EBS, and how the entire snapshots are configured, how we can define the entire lifecycle managers. And then we are going to discuss on the components of load balancing and other components step by step as we move further with the entire module. All right.
Yeah, one quick question here. Yeah.
Yeah, Arun,
So
please.
Neeraj, you were using Mobix term to connect to this instance via the SSH client. So
Right.
how about using that in Mac OS? I could see this will run only on
Inbuilt.
Windows platform.
Sure. Not a problem. I'll be showcasing on Mac as well. So for Mac has we can say inbuilt SSH client already available. So for you, when you're using
Yeah.
Mac, so we can, first of all, you have to download the key pair. And first of all, you need to change the access of the key pair as well. So for doing that, we can use a command such as chmod. So you can use
Okay.
chmod to change the file, we can say the permissions, and chmod we have to set it to 400. And then you have to specify the location of the file. For example, let's suppose you have stored a file in users. Let's say you have you're using me as Arun, right, for your
Yeah.
Mac. And then you have under downloads, you have the key file available as such as key1.pem. So first of all, you have to run this entire statement. You can replace the location as per your current location of the file. And then
Okay.
afterwards, you have to use a command such as SSH in interactive mode. And then you have to specify the same key file location. Suppose this is a key file location for you. Then you have to specify the key location and then space. Then you have to specify the username. Now currently we have chosen the username as Ubuntu. We can choose Ubuntu @ the IP address of the instance. For example, here we have the IP address. So here we have to enter the IP address and then we are good to go.
Thanks.
So if you want, let me share this entire with you all. So you can also run this. Here you go. And okay, and response. So once the instance I can have multiple applications and the key pair is, for instance, is this right? Yes, Rizwan. That's how it is structured. Is it clear now? All right, so I guess it's almost time now. So let's say we wrap it up for today, guys, and keep on practicing on whatever we have discussed so that we have a complete clarity on the entire process here. And let's connect at the same time next week to continue our journey on AWS. Have a great weekend ahead, guys, and let's connect at the same time next week to continue our journey on AWS. Thank you so much. Have a great weekend ahead. Take care. Bye-bye.